asked a question. Actually, I'm going to go back to Erin's point from yesterday, because she had an awesome point yesterday. This was the data we were playing with at the very end of class yesterday. Very end of class. And I want to start getting you guys used to a word called average. And I think we did a pretty good job of explaining what an average was yesterday. I'm going to slide this up. The board. When we talk about the word average, what do we mean? When you hear the word average, what's anything you think of when you hear the word average? Go!
Equal amounts of, I don't know.
Go, Shelby, go! That's the way I think of it.
Equal amounts to each.
Right! To each item. To each, yeah. So if you've got an average of a certain data set, whatever you're averaging, it means that each element of that data set is going to have the same amount if you share equally whatever the grand total that they have is. That's good. That's good. When I asked yesterday, somebody said, add everything up and divide by how many you got. That's exactly right, too. That's the mathematical definition of what Shelby just said. You add everything up that you've got and you divide by how many you've got. That's exactly right. So what I want to do is I want to look at our data from yesterday. I want to look at our data from yesterday, both what we collected and also what we theorized on, and something that Erin said very, very cleverly halfway through that. So we did 2 experiments, actually like 4 or 5 experiments yesterday. I want to focus on 2 of them. One was the number of times we have to flip until we see a repeat. That was one of the data sets we looked at yesterday. This was the data we collected yesterday. 108 of us needed exactly 2 flips until we saw a repeat, so heads, heads, or tails, tails. And then 81 of us needed 3 flips until we saw a repeat, so heads, tails, heads, or tails, heads, tails. And that's it. You can't have more than 3 flips, because if you flip 3 times, you had to see 2 of something in there at some point. We're going to extend this out later on today with the quiz I just gave you with cards, and then later on with dice as well. So we'll do the whole shebang. So the question is, on average, how many times do I have to flip until we see a repeat? So on average, what's the average number of times that I have to flip until I see a repeat? Now we came up with answers yesterday. We came up with answers 2 different ways, and I love them both. I love them. Remember this? Yeah, remember this now. We came up with answers two different ways, and I love them both. And I want to talk about both of them now. So on average, how many times do we have to flip until we see a repeat? What's one way we answered this?
2.5.
2.5 was it? Where did that 2.5 come from?
It was like 2 plus 2 plus 3 plus 3 divided by...
Good. No, that's this one. That's one of the ways we attacked this one.
Did that one come up to 2.4?
This did, if we look at our data we collected. But we didn't, to answer, you guys are both answering it correctly 2 different ways, and it did come up to 2.4, and your comment was, they're about the same. Hold that thought, hold that thought. Very, very good. So one way to look at this is say, okay, let's think about it. If we think about the average number of times it's going to take us to flip this coin until we see something again. Just so you know, this might sound like a stupid question. This is exactly the question Apple had to deal with a few years back when customers started complaining about their iPods. You might remember this. There was a complaint when the iPod Shuffle came out, we did it in 244 a different way, that we were hearing too many of certain bands on our iPod Shuffles. In other words, the shuffle, the idea of the iPod Shuffle is you put a bunch of music on it, you press play, and it randomly throws songs. It's not random. That's what customers were saying.
That's what they think.
It's not random. So what Apple has to do is they have to know what random looks like first, then they can compare the results against random. So this is kind of the mathematics that had to be done to answer the question. Good. Hold that thought, we'll come back to that. So, one way of approaching this, I'm going to mute the screen real quick so we don't need the data right now, is to figure out how many different ways the experiment could have happened. So one way would be to go heads, heads. Then you'd be done, right? That would be out in 2. So you could put 2 in the numerator, and that would be heads, heads, and you're done. Heads, heads, and you're done. Well, you'd also go tails, tails. That's 2. Tails, tails. But what if you didn't go heads, heads? What if you went heads, tails? Well, then you have to flip.
3.
You have to flip a 3rd time, don't you? So if you went heads, tails, you'd have to go heads, tails, heads, wouldn't you? And then we did heads, tails,
Heads.
heads again, right? So we go heads, tails, tails. That would be a repeat, yes? Or we go heads, tails, tails. So I think one of the ways we did it was this. Now, we did this divided by 4, and we ended up with 2.5, I believe, correct? 2.5, right? Now, what's a problem with that? I'll put this up here. Heads, tails, tails. Heads, tails, heads. What's a problem with this logic?
Is it assuming that you're always gonna get you're always gonna get that secret?
Well, we've forgotten a couple sequences, haven't we?
I was to say, you could do more than.
There's more than just those 4. Aren't there also tails, heads, heads, and tails, heads, tails? So technically, now, I'm going to leave this up. We did this yesterday, and I want to come back to that argument. But this is a problem. We haven't allowed for all of the outcomes if we do it this way. Now, the way we did do it in class yesterday, I want to call this number 2. We're going to come back to number 3. We're going to adjust this for the correctness of knowing that we missed a couple. Okay, we're going to come back to this. The reason I'm starting with this is this can be a pain in the butt to do. As you guys, if you guys have looked at the project for next week, you can see that counting like that can be a pain because you have to sit there and micromanage, and it can be a pain to do that. But another way of dealing with it is forgetting that and saying, all right, forget this for a second. Slash, we'll come back to it. Look at it via our data. Look at it via our data. So this is via the data that we collected. Okay? The data we collected, we saw 108 of you took two to stop, and 81 of you took 3 to stop. Now those 3, I didn't have you write down the way you got the 3. I didn't write down if it was heads, tails, heads, or heads, tails, tails, or tails, heads, tails, or tails, heads, heads. We didn't write down how they came out. We just wrote down that it came out that way, if that makes sense. Yes, please. So now, how did we calculate the average using this idea? How did we calculate the average using our data? So we got this. Here's our distribution. Number of flips, and how many of us got that? 108 of us took 2 flips, and 81 of us took 3. How did we use that data to figure out the average? Go ahead, Tom.
You weighted it essentially.
Exactly. You weighted the average. It's called a weighted average. It's the same thing you guys use when you do your GPA. You have to weight your grades in each class with how much the class is worth. This class is worth 4 credits. Your CrossFit class is worth 1. Your speech class, I think, is 3. Your writing class is 4. Your library 127 is 2. I mean, all these classes, for whatever reason, have different weights. Right? Total fit is 1, hardest 1 credit you'll have in your life. But there's all these different credits that you have to weight, and the same thing has to happen here. So what we did to do the average here, the average number of flips, we divided by 189, didn't we? Because that was the number of data points we had. We had 189 results in our data set. And that's inarguable. That's inarguable. I know we're going to argue that 4 over there, aren't we? Yeah, we're going to have to argue that 4. So, how did we weight the 2? Well,
2 times 108.
nice. We could go 2 plus 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 2 or we do 108 times 2. That's why we invented multiplication. So we did 2 times 108, which is the same as 2 plus 2 plus 2 plus 2 plus 2. It's the same as this, but instead of writing it just twice, you have to write it 108 times, but that's why we invented multiplication. Good? Plus 3 times 81. Katie, you asked an awesome question. I think it was you, Katie, yesterday. When you said, doesn't the 189 divide off now? I think that was you. Somebody asked that question. It was a fantastic question. I'm going to give you credit for it.
Nice.
Because I can't remember who asked it.
Sorry.
The question was,
Somebody under the bottom.
so can you cross off the 189 and the 189? And you can't because of order of operations. You have to combine that numerator first before you can divide by the 189. And this came out to 2.4, yes? This came out to 2.4. To which Aaron replied, holy crap, it's pretty close. It's only off by 1/10 of a flip. To which I said, hell yeah. And then I wish we had half an hour more yesterday. I know you didn't. I wish we had half an hour more yesterday because I wanted to take this further because I knew what had happened over there. So now what I want to do is I want to go back and look at our original result. Because this is one of those awesome times in math classes where you get the right answer, but you did the math wrong to get it. And I love that. Because students always want to know, wait a minute, time out. How could I get the right answer on the wrong numbers? And most times it's due to something pretty straightforward. So let me ask you a question. I'm going to stop right now, make sure we're all okay with where we are. That's a weighted average. This technically you could call a weighted average because it's 1 times 2 plus 1 times 2 plus 1 times 2. I mean, you could, nobody calls it that, but that's a textbook weighted average. So far? Fantastic. Let's come back to the first one now.